Yesterday we started preview of calculus. You are in your notes. The table of contents has been made. You skipped how many pages to make sure Charlie's on board? At least 2. You're on page 1 of your notes, even though it's really like 3 pages in. How many of you guys numbered your entire notebook last night? No? During Netflix? Just kidding. You're all doing government homework. Anyway, so. No. All right. Yesterday, did we write down very many notes? No. Good thing, Charlie. It was just this page. What is calculus? We talked about how calculus makes everything more interesting because it is the math of change, and our world is continuously changing. Hey, so we need calculus. What real-life application? So, does anybody know, or can anybody brainstorm any fields that need, whether in recent times or ever since the beginning of the field, need calculus? Engineering. Yep. What else? Physics. What else? Math teacher. What else?
Science.
Microwave.
Science.
Sometimes.
Scientist.
Calculus can come into chemistry eventually.
Cross country.
Architects. There's a lot of math involved. I'm not sure if calculus specifically is, but you have to worry about movement. Rocket science
There's
definitely.
a name for it, but it's like projecting the rate at which like a disease spreads or something like that. It's something to do with biology.
Yeah. With the rate of change of So biology too. What else? Economics. Huge field where calculus is being applied today in the last 10 years. I talked to an economics professor retired from USC who was like, it's crazy how much the calculus, he was trying to tell me how important my job was to do calculus. Anyway, it was cool. So economics is a huge one. Economics majors, whoo-hoo, they're intense. Anyway, so coming on back. Raul's being an economics major. At least for right now. He wants to be a lawyer eventually. Anyway, so he was just talking to me at the beginning of the year. We're in section 1.1, preview of calculus. We're not going to spend lots of time on all the different applications of calculus we're going to see this year. But you do see everything from holes, and you're like, holes are basic, whatever, that was algebra 1, to slopes. This one you're used to. This one might be a little different. We'll get back to that in a second. So different lines that go through points to motion. Curvature, we're not going to deal a lot with, but heights of curves, definitely. What you know based on, what you don't know. Interesting. We have different tangent, planes to spheres and to surfaces. We have areas. We have work, which is a physicsy thing. We're not going to spend tons of time on, but if you take a physics class, whether here or in college, you'll introduce this sort of physics. Here in college, you'll have more calculus involved, depending on what kind of physics you take. There's calculus-based and non-calculus-based. There's volumes. There's mass. There's all sorts of. There are even sums of infinite series. That has to do with calculus. Yes, indeed. There are all sorts of different things we can talk about, but it all comes down to 2 problems. It all comes down to 2 problems. Every group have an expo, one of these in a napkin. It all comes down to 2 problems. I want you guys in your notes to go ahead and take a second. Get this problem in your notes. All of calculus has as its foundation 2 problems. And they must be 2 whopper problems in order for all of these different applications to come out. If you guys know, math is very closely tied to philosophy, at least throughout the history of the development of math. What we would call mathematicians, or those that made advances in the math field. As you guys are staring at this problem, why is it a problem in the first place? Based on what we've learned, why would a tangent line be a problem? How do you come up with any line? 2 points. You don't need 2 points in the slope. What are the things that you do need though?
The slope.
1 point in a slope, right? Or, what else? Either 1 point in a slope Why 2 points? Why is that sufficient?
Better.
It's better because you can use the slope formula, change in y over change in x, right? You can either have 1 point in a slope to find a line, you could have 2 points using the slope formula, hopefully using point slope form. We've talked about how important that is. So to make an equation of a line, which is kind of from our summer packet, hopefully, of any line. And what equation of a line am I specifically talking about? Point slope. Believe me, it's just the most useful. What's something else that you could be given?
1 point.
1 point and a clue, right? What's an example of 1 point and a clue? Yeah, like a slope is perpendicular or parallel. Remember from the summer packet? If it's parallel, what's that true, or what's true?
The slope is the same.
They give you some other line, the slope is the same. If it's perpendicular, they give you some other line and the slope is the
Negative.
opposite reciprocal. If it's negative, the original, then it's positive and then you flip it. So like 2 would be negative 1/2. Negative 1/3 would be positive 3 if you're looking for perpendicular slopes. They could give you technically a slope and a clue, but that's a little more awkward. Those are usually the different types of information you're given. What's the dilemma of the picture up above if they give you y equals f of x, a function? What does this kind of look like? Sort of, kind of, maybe. Yeah, looks like a parabola, right? It could be, what do you guys think if we were to give it an equation? Y equals, it's positive x squared,
And then
up 1, but is that the vertex?
No.
So we could say plus 1 maybe?
Yeah.
Up 1 and over 1/2, is that what you want to do?
Sure.
You want to do this? X minus h and y minus k? It's okay. But if this was the equation of our line, they give us this equation, we're just kind of making one up. Pretending the vertex is, I don't know, here-ish. And this is 1. I don't know. And this would be 1/2. And then they say, hey, find a tangent line at point P. Do we have a point? Yes. Do we have 2 points? No. Do we have a point? Yes. Do we have the slope? Do we have a clue? Yes. And if you guys remember from last year, I like to mark my clues with a... We have a clue. We have a function. We have a function to which the tangent line is supposed to skim beyond. You found it. It's right there. But the problem is we have to learn how to use this clue in order to, from this equation, figure out the slope at point P. That is the question. That is the problem. That is the dilemma. So we're going to do a quick exploration to help us with this dilemma. You guys are going to need at least one calculator per group. You're going to need one person to be drawing on the graph that's fairly precise. You're going to need some sort of straight edge, which could just be the edge of your composition book, or it could be the edge of your forever card. You need some sort of straight edge. And you need someone to have some scratch paper to do some math. Now, hold on real quick. Listen. 5, 4, 3, 2, quiet, and 1. Okay, you guys have this thing called a spiral, right?
Yeah.
And you're kind of like, what's the spiral for? Can we get out the spiral real fast? Not requiring you to have a binder, I'm requiring you to have a spiral. Now, ready? I want you guys to open your spiral. From the front, like the normal way. Like, open the cover. First page. Very first page of your spiral should be blank for the most part. Tear out one that's not blank. On the very top of the first page, I want you guys to write homework. Guess what? Starting from the front, you're going to put all your homework assignments, never tearing out a one.
Yes.
Don't have to lose papers. Don't have to squish them and ruin your books. You squished them in your books last year and ruin them. Just bring it to class every day. You'll always have your homework. Now, some of you are like, what if I'm absent? Well, you shouldn't be doing the next homework assignment until you do the previous one either, because math bills, right? What if you're like, but I'm a slacker and I don't do my homework and I do it the night before the test? Not an option anymore, because if you want to do any homework, you have to do it sequentially, finish it, and then go on to the next assignment. What if I have a question? Leave some blank space like you always did, right? And then keep going. Sound good? Now hold on. I want you to turn your notebook upside down. Or if you're left-handed, just kind of flip it to the back. If you're right-handed, flip it upside down. And go to the very back of your spiral. If you're left-handed, you don't want to flip it upside down. What? It's connected. That's cool. Okay, so homework. Right-handed people, you're probably going to want to flip it upside down and do it this way if you want to write this way. Or you could just do it this way and, feel the struggles of a left-handed person most of the time. I want you guys here to write classwork. So any openers, any warm-ups, any group explorations where you need scratch paper, you never have to be afraid of having not enough paper ever again. Homework, we're working forwards. Classwork, we're working backwards.
What do we do when they meet?
Getting your assignment. Like, yeah, that's what I figured. It's up to you. All right, so hold on. Since we're doing a group exploration, are we in the back or are we in the front?
We're in the back.
Perfect. I want you guys to go ahead. We're in section 1.1. Label it. You don't have to do new pages for classwork. For homework, yes, you do, in the sense that when you start a new homework, you start a new page. But classwork, just keep them going. Draw a quick line underneath. But I want you to label section 1.1, group exploration. Section 1.1, group exploration. If you want. I like it that way because then my hand's not hitting the spiral. You can do it upside down if you want. That's the way I would like it. But some of you are like, I can't write upside down with that blank space at the bottom. All right, just feel the struggles of the left-handed person most of the time. There it is. I went too fast. There it is. Okay, I'm going to change this up just a little bit because of how your graph is oriented. The question, I want you guys, your groups, to look at your green sheet, your teal sheet, whatever sheet's in front of you. What function is graphed on there for you? Hey, look at this quick exploration. What function are we dealing with? Now, hold on. I'm going to change this up just a little bit. And I actually... Guys, can you see 1.5 and 1.1 on that graph very clearly?
No.
No. But what can you see? You can't come from the right so good, but you can come from the left. And what am I saying from the left? What number are we approaching? What x value from all the things I'm erasing?
1.
At what point did I draw for you on the graph besides 0, 0?
1, 1.
1, 1, right? Now, you guys are reading as I fill in the new numbers of what I want you guys to do. Okay? And technically, let's see. 0.4, 0.6. Let's start with, let me make it a little bit thinner or else no one's going to be able to read it. Okay. We're going to start with 0.4. Then we're going to go to 0.8. Then we're going to go to 0.9. We're going to go to 0.99, and I'm pretty sure we're not going to be able to see much closer than that, so I'm going to totally erase the 5th point entirely. Now, what does, those of you that started reading, what does the exploration say as far as what you're supposed to do? Find the slopes. Now, what slopes? Slopes, you need 2 points. You need 2 points. You're going to take each one, and you're going to find the slope between this point and this point. Right? So let me just go ahead and let's do one all together. But first of all, my precise ones. Oh, it's out of order. That's what's weird. There we go. My precise ones. Do you have 0.4 and 0.8 marked on your graph? No. So first thing is we have to go ahead and make sure that our graphs are partitioned. Ooh, that's a snazzy word. What do I mean by partitioned? Separated. You need to add some tick marks that are pretty precise. You need to add some tick marks that are pretty precise. So maybe like a 0.2, 0.4, 0.6, 0.8. Hey, not bad. Might be a little off. With an expo on your graph, you need to go ahead and section it off by 0.2s. using the expo. And if you make a mistake, don't worry, just erase it with your napkin. Keep going. 0.2, 0.4, 0.6, 0.8. Now go ahead and label 0.4 and 0.8. Yeah. We're going to have to do the math of the slopes. But you can use the graph with the expo all together. Does that make sense? You don't have to draw the pictures. So you're going to have to do the math of the slopes using your calculator for sure, but in your classwork. Okay? Now hold on. What else do we need besides 0.4 and 0.8? 0.9. And then 0.99. Okay. Question. As I progress 0.4, 0.8, 0.9, and 0.99, you can label up above if you need to get room. Am I approaching 1? Oh. And as you, with your straight edge, as you connect these lines, which straight edge, I know, it's cheap. Exactly. Start right here. Oh, come on, rotate. Is that close enough?
Yes.
Gotta be precise, right? Okay. What am I connecting right now? The point at 0.4, which is the first point, and the point at my point of tangency, which is 1. Now I know. Mine's cool because I can be really far off. It'll still be pretty straight. But with your straight edge, you're going to connect that. Okay? Now, here's what I want you guys in the group that are not drawing these snazzy lines. Oh, I don't like that very much. That's okay. A little better? Okay. You guys in the group that aren't drawing and aren't setting this all up, you need to figure out and maybe split it amongst the group what the slope is of that line. How do I do that? You know that because you know that this point is 1, 1. What's that point? 0.4. Plug it in to your function. What's 0.4 squared? So then I can do, remember y2 minus y1 all over x2 minus x1, so I'll do 1 minus 0.16. Find me the slope. Find me the slope. So people in the groups, you need to find the slope between 0.4 and 1, 0.8 and 1, 0.9 and 1, 0.99 and 1. Person drawing, you need to have each of the graphs drawn, and at the end, hopefully we'll see something happening. Ready, go. Finish. Use your calculator. Plug it into the function. Remember, if we have it, that's easy to plug into the function.
42 over 3.
Hey, remember in your classwork, maybe I'm grading classwork now. Write down the slopes. You don't have to write down the graphs, but write down the slopes. If you want to write down the graphs, that's great as well.
It's going to be really difficult. Straight edge should cover everything's all going to be wrong.
Point is 0.8, right?
Because it's 1.4, isn't it 84.8? You messed up. So 1 squared is
It comes up in everything. 1.4 cents.
It's going to be kind of hard to write the slopes at the top. You guys might want to adjust and write the slopes at the bottom. I don't know, my people writing. It's up to you, but that might make life a little bit easier.
Oh, it's
Find the slopes for each one.
What's 0.8 squared? That's 64.64. Alright.
So it's slope curve. The line from 0.4 to 1. That's the next one's 0.8. Huh? What does 0.8 equal?
1.8 is 9.
No, 0.8. You go from 0.4.8 to 9.9.
Okay, now it's 0.8.
What is that? That's 6. 46?
Used to. I think someone last year used them all up. I'll check them out. Not like last year.
We're at 0.8.
That's the 0.9 one. The 0.8 one to square the x value. To find this one. Yeah. So the next.
Now it,
Alright.
You got your
the slope again is just y.
Did we just start?
Okay, now 199 squared.
I always made my slopes in fractions. You want them in decimals. That's all off the line.
Yeah, so you take one y, so y, minus the other one.
Yeah.
Somebody, some group, let's do group number 4. What was the slope of the first one between 0.4 and 0.16?
1.4.
1.4. Group number
Oh, I didn't know.
Okay, what was it? What was it? Fine. Oh, that's right. She got it. Group number 6. What was the slope of the next one? Uh-oh, not yet. We'll come back to you. Keep working on that one. Group number 2. What was the slope of the third one, which was between 0.9 and 1? No, sorry, 0.8 and 1. No, 0.4, 0.8, 0.9 was the third, right? Okay, sorry. Oh, you didn't find 0.9 yet? Keep working.
Well, that's a fraction.
You would do, remember, y2 minus y1 all over x2 minus x1. And plugging it in, you would end up with 0.84 all over 0.6, which ends up going in to be like 0.60. That would be 1 and 0.24 over 0.20. Oh, divide it. Divide it. Does that make sense? So that equals 1.1. Number 6, did you get the second one? For 0.8. Group number 5 stole it. 1.8, does that sound good to you?
What happened is
Isn't 0.8? What's the y value for 0.8? Plug it into x squared, right?
Yeah.
So that'd be 1 minus 0.64 all over 1 minus 0.8. What do you guys get? No, you're good. It's okay. Okay. There's 4 people in the room.
It's 36. It's not 46. Because we used 13 on this one, right?
Okay. Group number 2, you're still working on the third one, right? He's the tangent one. But we can't solve for him outright, remember?
13 over 2.
1.8. Group number 2, did you give me the next slope?
13. That was not.
Because that would be 0.9 and 0.81, right? So 1 minus 0.9, no, 0.81. All over 1 minus 0.9. And what'd you get, Sarah? 1.9. Interesting. Any group that has the last one for 0.99, star. Does it be 1 minus, what's 0.99 squared? There we go. You can use your calculator, right? Sorry, you got 1.8, what was it? Sorry? 99? Hey kiddos, if we remember the idea of limits and how limits approach, what do the slopes, as the points that we're choosing removed from 1, as that distance gets smaller and smaller, distance between 0.4 and 1, 0.8 and 1, 0.9 and 1, 0.99 and 1, as those points get closer, what happens to the slopes? They are approaching a slope of 2. What? Interesting. Now, hold on. Pause. Did we learn how to do power rule for derivatives? Oh, I'm going there already? Yes. Did we learn how to do power rule for derivatives?
Yes.
What is, if y equals x squared, what is y prime, or dy dx? What is the derivative? 2x. What does the derivative do?
So the tangent line.
Which one do you like better? This exploration for every single tangent line slope you ever have to find, which would work. Or take the derivative, plug it in, slope. Now, we'll get back to this. This isn't the only day we're covering. But big problem number 1, finding a tangent line, which can also be corresponded to an instantaneous rate. Oh, physics, coming back. Economics, chemistry, biology. Anyway, coming back. Finding the slope of a tangent line can be found with our exploration anytime. All you have to do is pick points that are a little bit away, a lot closer, lot closer, and see what the slopes are approaching. Which is called, we're approaching, x is approaching 1, change in x, delta x is approaching 0, difference quotient is approaching 0, slopes are approaching slope of the tangent line, which is the same as the value of the derivative at the point. Big question number 1 answered with derivatives, but derivatives come from limits. Now, group exploration part 2. There's another one?
Yes.
Okay. Napkin, graph, erase. Spiral, back, classwork, some work shown. Okay, now hold on, wait, make sure. Is your work labeled section 1.1, group exploration part 1? Now, group exploration part 2. Now, hold on, I know. Look at the clock. 3 minutes. Let me talk through directions for part 2, and you might be like, why are you spending so much time on the preview section? Because it sets up our entire year, number 1. And number 2, on the AP, exploration part number 2, AP free response. That's a thing named calculus? Yes. Basically show a problem and explain why. Not why 1 plus 1 is 2, but why you chose 2 through the following procedure and why it proves what you need to prove. Coming back. There are problems on the AP that require you to be able to find areas of rectangles and add them up. So we're actually doing something I usually do at the very beginning of second semester, or maybe even the month in. We're going to do it as an exploration tomorrow, so that when you get there second semester and there's all this calculus crowding your brain, you will have already seen it and played with it a little bit. Sound good? Okay. Good news is section 1.1, not due tomorrow, Wednesday. There was homework due tomorrow. It's going to be due Thursday, but pause. Can you do part of it?
Yeah.
Anything dealing with tangent line problem. Anything dealing with area, you can't do. Now hold on, you can go ahead and close stuff, but I need attention back here and quiet. So close it and then stop. Silence in 5-4, including silence of closing things and zipping things. 1, done. Done. Hands off. Okay. Tomorrow, when you get in, do you already have that graph drawn on the teal thing that someone from your group is going to pick up along with an expo and a napkin? Yes. What are we going to be exploring? Number 1, classwork in the back of your spiral, part number 2. We are going to be exploring the area between 0, x is 0, and x is 1, all that shadedness. The question, do we know how to find the area between 0 and 1, all the shadedness with geometry? No, it's not a triangle, it's not a rectangle. But what can we do? Portion it up into 1, 2, 3, 4 fifths, and find the areas of all of those rectangles. Portion it into maybe, is this still fifths? Yeah, it is. The question, guys, how do you find areas of rectangles? Area equals base times height. Can we figure out what base is going to be for each of these if we cut them equally?
1 divided by
So if there's 1, 2, 3, 4, 5, then the base for this one is going to be 1/5 or 0.2, right? What are the heights going to be?
the y. Oh, it's based
The
on
y values
x squared.
for this one, for rectangle number 1, right? Rectangle number 1 is going to have a height of, if that's 1, what's that if it's 0.2 away? 0.8. 0.8, plug it in. Does that make sense? All right, cool kids, we're starting with this tomorrow. It's going to be on the screen. Make sure you come in. Homework is due. I'll change it on the calendar. Thursday. 0 period tomorrow morning if you want to stamp. You can ask about the limit stove too. You can ask about